Yes, welcome to Electric Circuits Lab. Uh, in today's class, we are going to see Kirchhoff's current law. Okay, verification of Kirchhoff's current law. As usual, this is your circuit diagram, then tabulation. So we need to verify Kirchhoff's current law. We need to add these two branch currents. This branch current must be equal to the first branch. So this is the input current I1, I2 and I3 are leaving current from the same node. So we are going to verify the Kirchhoff's law at this node A in this circuit diagram. Okay. So these are our corresponding readings we need to tabulate in this tabulation. The procedure in usual laboratory, we will do the voltage from steps of 5 volt. We'll increase the input voltage and we will take the readings up to 30 volt. Okay. This is the verification part. You need to add the branch currents. The sum of the branch currents must be equal to the input branch, that is I1. Without making much delay, we will enter into the simulation platform, Tinkercad. Before that, this is your question. This is your input voltage, 12 volt you need to apply. The R1, R2 and R3 values are given in the question paper. Okay, 100 ohm, 2.2 kilo ohm and 1 kilo ohm. Then you need to connect 3 ammeters in all the 3 branches. Then we need to take the readings and we need to tabulate it. So the sum of these two branch currents I1 plus I2 must be equal to my I1. So now we are going to start do the simulation. First we will give the connection step by step. Let me go to the Tinkercad software first of all. Go to Tinkercad software. You know how to log in and all. In previous videos, we have given the procedure. Now straight away, I'm going to click create new circuit. Create new circuit. Then the name of the experiment, as usual, you need to type your register number. Okay, let me type my register number. Followed by, I'm going to select the all components option. Then only I will get all the components available in the particular software. First, I need a resistor. Please drag and drop the resistor in the workplace. Then go to the below components. In that, we need to select breadboard first. As usual, breadboard first. Drag and drop it in the workplace. Yes. Then go and select the power supply unit followed by the multimeter. That's all. So in Kirchhoff's current law, we need ammeters. How many ammeters we need? As per the circuit diagram, we need 3 ammeters. Okay. How to get 3 ammeters? Yes. Simply Control C and Control V. You will get 3 multimeters. Now what I need to do? I need to change the default voltmeter reading as an ammeter. Do it in all the 3. That's all. Now we have got 3 ammeters in our hand. Then resistors, similarly I need to select any one resistor, Control C and Control V. You will get the duplicate resistor. That's all. Now I need to select the resistor value as per my question. What is the R1 value? 100 ohm. What is R2 value? 2.2 kilo ohm. What is R3 value? 1 kilo ohm. So select first resistor and change it as a 100 ohm. So R1 value is 100 ohm. What is R2 value? 2.2 kilo ohm. 2.2 kilo ohm. What is R3 value? It is by default is 1 kilo ohm. I no need to alter anything. Okay. Let me start give the connection. Yes. First, as usual, we will power the breadboard. Take positive wire, connect the positive terminal of your power supply with the breadboard and give the color as red color. Then take negative supply from the power supply unit, then change the color as black. That's all. Now refer your circuit diagram once. Positive terminal of my power supply to the first R1 resistor I need to connect. Okay, let me keep the circuit diagram sideways, thereby you can refer and do it. So let me take the R1 resistor first, rotate the R1 resistor. Okay, check the connection. Positive terminal to the one end of the R1 resistor. Okay, one end of the R1 resistor. So what we will do, we will bring the R1 resistor first to the breadboard, and we will connect the one end of the R1 resistor to my power supply. Okay, change the color into red color. That's all. Then from the other end of the R1 resistor to the positive terminal of my ammeter, bring the ammeter, first ammeter. Let me keep other resistor sideways. Yes. Yes. Now positive terminal of the ammeter need to connect it to the other end of the resistor, isn't it? Yes. Change the color as red color. That's all. Now what we have to do? The negative terminal of the ammeter, we need to connect it to the one end of the remaining two resistor, that is R2 and R3. So what we will do, first we will take R2 resistor and place it in the breadboard. Similarly, we will take R3 resistor also and we will keep it in the breadboard. Then let me join R1 and R2 resistor 1 and together. Okay, let me connect R1 and R2 resistor 1 and together. Then connect it in the negative terminal of my ammeter. Take one wire from the negative terminal of the ammeter and connect it to the same node. Okay. If you want, keep it as a black wire, no issue. Okay, that's all. Then please refer circuit diagram and we will proceed. What we need to do? Then I need to take the second ammeter. Where is our second ammeter? Let me take this. Consider this ammeter as a second ammeter. It is going to measure the current I2. Where I need to connect? The other end of the R2 resistor to the positive terminal of the second ammeter. So this is my R2. From the R2 resistor, other end of the R2 terminal, I need to connect it to the positive terminal of the second ammeter. Okay. In this way, I need to connect. So let me make this wire as a red color. That's all. Then the negative terminal of the same ammeter need to be connected to the negative terminal of my source. Take the negative terminal and connect it to the source negative. That's all. That's all. So similarly, I need to connect third ammeter in series with the R3 resistor. Bring the third ammeter. As usual, another end of the R3 resistor need to be connected to the positive terminal of the third ammeter. See? Yes. Give it as a red color. Okay. Then see again the third ammeter also need to be connected to the negative terminal of the power supply. Okay. Take the negative terminal of the third ammeter and connect it to the negative supply available in the breadboard. Is it clear to everyone? Yes. Now what we need to do, after giving the connection, we need to start simulate the experiment. Okay. So please verify one circuit diagram once. The value of resistor R1 is 100 ohm, R2 is 2.2 kilo ohm, R3 is 1 kilo ohm. Now what we are going to do, we are going to start simulate. Click start simulation. So by default, it will give 5 volt. Default, it will give 5 volt. But as for the question, I need to give it as a 12 volt. Click the power supply unit and select the input voltage as a 12 volt. That's all. Now I need to note down the individual ammeter readings. Where I need to note down? Take the tabulation, then note down the readings. So first reading, only one reading we are going to take. The input voltage is how much? As per the question, the input voltage is 12 volt. So we given the same input voltage in the regulator power supply. Now I need to note down the corresponding ammeter readings. First ammeter reading 15.2 milliampere. The second one how much? 4.76 milliampere. Third one how much? It is 10.5 milliampere. That's all. The reading, tabulation reading is over. Then the last one is the calculation part. What I need to do in this tabulation, I need to add I2 and I3 readings. I2 reading is 4.76, I3 is 10.5. If I add these two, readings, if I add I1 and I2 readings, I will get the value as how much? I will get the value as 15.26. That's all. What is the verification part remaining? What is the verification part remaining? I need to verify Kirchhoff's current law. How I need to verify? I1 value must be equal to the individual branch currents. What is that? I1 plus I2. Isn't it? That's all. Now add these two values and verify. I1 reading is how much? 15.2. That is, the 15.2 is approximately equal to what? Approximately equal to 15.26. That's all. So the Kirchhoff's current law is verified. So thank you for watching. If you have any doubt regarding this, please contact.